Have you ever wondered how a carburetor works? Probably not. You probably don't know what one is. I'm Jeremy.
And I'm Albert. And today we're going to talk about how a carburetor works and how Bernoulli's principle dictates the function of a carburetor and allows an engine to operate using vacuum and deforming volume. Now we will demonstrate how Bernoulli's principle works on the carburetor using a vacuum. So the carburetors, shown here, sit on the engine. Right there. Now what happens is, once your engine is started, the piston, shown here, goes down and the intake valve opens up. So as the piston moves down in its enclosure, it creates a vacuum, pulling the air and gasoline through the carburetor into the engine. The valve shuts, the piston moves up, compressing the air and the gas, adding energy to the system. Once the piston reaches the top, the spark from the spark plug sparks, igniting the air and gasoline, forcing the piston down, creating the power stroke. Once it finishes the power stroke, your exhaust valve opens up. The piston returns up, forcing the exhaust gases out of the engine, and then it closes.
So here we see the cross-section of our carburetor. And before we hooked up the vacuum, and that would be on this side here, which sucked in air, and we saw this piston valve rise up. And this happens when we accelerate. This butterfly valve goes horizontal, which allows more air to pass through here. And from equal flow rate, where Q in equals Q out, since B has a larger area here than at A is going to have a larger velocity than what B has. And this larger velocity will create a lower pressure here, which pulls gas through this main jet towards the piston, which you'll see on this slide. And we see some of our assumptions that I said before, where velocity at A is larger than at B, and the area at B is less than A. And if we stick this velocity into our Bernoulli's equation, which we learned, and cross some things out, we're left with this equation here, where the density and the 2's are constant, so those can cancel out. So we're basically left with the pressure at A plus the velocity at A squared equals the pressure at B plus the velocity at B squared. And since our velocity at A is larger, it's going to have a lower pressure to make sure the equation is the same on both sides. And this goes with the piston, because when the piston pulls down, it has a deforming volume, which lowers the pressure, which creates the vacuum, which actually pulls the gas out of the carburetor here into the piston. And when it rises up, that fuel will compress with the air and create an explosion, which will push the piston back down and then go out to the rest of the engine.